number 2, a plane travel at the 3 times or speed of the sound. If the speed of sound in air is 343 meters per second, how far it travel in 10 minutes? So now the plane, the speed of the plane is 3 times speed of sound, and speed of the sound here is a 343, so meaning we have a 343. This is the speed of the plane, right? And the time taken here for is 10 minutes, right? So what is how far? Meaning we have use equation. The velocity is a distance of displacement divided by time t. So how far here is referred to the displacement. So this displacement s is equal to v times t, and v here is the speed here is 3 times 343 and divided by time t in 10 minutes. So convert to the second is time 10 times 60, right? So we have the s or displacement is 6.17 times 10 power of 5 meter, right? Continue to number B. A ball is thrown vertical upward. It reaches the maximum height and return to the initial position. Is the acceleration of the ball 0 at the maximum height? And state the reason for your answer. So if we draw the, let's say this is a ground surface. Okay, you start thrown upward or thrown vertical object to the upward. So this is direction of the a ball to the upward, and at the maximum edge the ball stop for a while, and after that start moving downward. And this is the process of if you throw the ball vertical upward, and here we have a final velocity at the maximum, not the final velocity, the maximum edge. Let's say this is the distance here. The distance here is h. So at the maximum here, so the v is equal to 0, right? But at the position here, because the object in the air, okay, influenced by the gravitation g. So gravitation acceleration is 9.81 meter per second, meaning here the acceleration a ball at the maximum height is accelerate, or at the value or the acceleration at the maximum height of the ball is not is equal to 0, but acceleration at the maximum here g is 9.81, sorry, this is meter per second square, right? Okay, sketch 2 graph displacement against times t and velocity against time t for the whole journey. So the process here, let's say the first part is the from ground to the maximum height. Let's say this is a S1, and the second part is a S2. Okay, the first part and the second part. So the first is a graph displacement s versus time t. So for the displacement s versus time t, for the first part here, we have if you throw ball upward, so meaning the velocity is a decrease, and the final velocity is equal to 0 at the maximum height. So here if you draw the graph s versus t, so we have the curve graph. So this is a increase the velocity, right? The first part here, and the second part at the maximum. That's why this is a maximum. This is a maximum S maximum, and after that the ball start moving downward. So here moving downward meaning we have a increase the value of the velocity, right here, but the velocity here, sorry, the direction of the ball is a negative. That's why if you let's say you calculate the gradient here, here we have a positive, here we have a negative, because this is opposite direction, right? Okay, so the next question asks you to plot graph velocity against time, right? So velocity against time t, right? Because we have a value v positive and negative, so we have the first part, velocity is decreased, so meaning we have a maximum velocity, and after that the velocity decrease and is equal to 0 here. Yeah, v is equal to 0, and after that the ball start moving downward. So moving downward meaning we have a negative acceleration. The second part here, this is referred to the v is a negative, that's why we have a negative, and we have an increase of velocity. Okay, so this is a negative v, and this is a v positive, right? And here we have the, okay, we continue here, we have the same the value of the time t, but different. This is graph s versus t and v versus t, right? Continue number C. Figure 1 show the ball is thrown from the top of the building toward the wall 60 meters away. Initial velocity of the ball is 20 meters per second. So this is 20 meters per second at the angle 40 degree to the horizontal. Okay, how much time is take to hit the wall? So meaning here, because the distance here, this is, let's say we have a range. So if you know, you can find the value of the range here by start by the equation, the speed is equal to the distance divided by time t, number 1, right? And now the range here, or s here, this is range, or s, or r is equal to 60 meter, and v here, because this is, we talk about the horizontal, that's why this is a vx here. So now this is divided by t, so now t is equal to 60 divided by vx here, resolve 20 to vx here, so ux we have a 20 cos 40. So this is t is equal to 3.92 second. Okay, number 1. And number 2, what is the distance between P and the position the ball strike the wall? So meaning here, maybe the ball's moving upward and start moving downward. Okay, so now maybe we have this is the point, right? The point that the ball strike the wall. So what is the distance here, right? What is the distance here, or s? So distance here is a high, or you can use the sy, the vertical axis, or y. So you can use the number 2 here. You can find the value of y by using the equation sy is equal to uy t minus half g t squared. So now sy here, sy uy, so resolve to the y-axis, this is uy 20, resolve to the y, so meaning we have a sine 40 times t times t minus half g t square. But the value of the t here is t is time of flight, right? You can use the value of the t here. You can use the value of the t here. So I write here. So the sy, the final answer for the sy is equal to negative 24.98 meter. So this is a distance because we have a sy, the direction of the ball, okay, is downward, so that's why we have a negative, and this is a distance 24.98 from the position here. This is, let's say, 0 and the direction downward, so we have a negative value here. And number 3, what is the speed of the ball when it strikes the wall? So let's say we have okay, this is the ball, okay, just before hit the wall, okay, the ball here, and the ball have a, let's say, velocity v here, and the v here you can resolve to the vx and resolve to the vy. So as you know, vx is always constant here. Vx is always constant from the initial to the final position. So we have a, for u vx, we have a 20, so you right here, so 20 cos 40, right? So this is a vx. So the problem here, because to calculate, to find the value of v, so I write here, okay, so we have a v, so this is what is the value of v. So now v here you can resolve to the vx and resolve to the vy, right? Okay, now to calculate the v here, so you can use a Pythagoras. So you draw the triangle here, so this is 90 degrees, so this is vx and this is vy direction to downward. So now you can find the value of the hypotenuse here. So the v here is equal to vy square plus vx square, right? So now the value of the vx is a 20 cos 40. So what is the value of the vy? So vy here you can use the equation vy square is equal to uy square minus 2g s, v square is equal to 2gs, right? Okay, I think it's not the equation. You can use another equation. V is equal to, this is vy, uy 2gt, because you already know the value of the time of flight, t here. So now here we have vy, uy here, you resolve, start from initial, is uy here is 20 cos 20, sorry, 20 sine 20 sine 40, right? And t is constant 9.81, and the time of flight we have already calculated from question number 1 is 3.92. So you can find the value of the vy here. So vy, so if you use the calculator, vy is equal to negative 25.6 meter per second, right? So now you can use the value of the vy here, and you have the value of the vx is 20 cos 90 to the equation here, so you can find the value of the v. So I write here the value v here is equal to 29.8 meter per second. So this is the answer for question number C3, right? Okay, that's all. Thank you. See you in the next video.